Hey everyone, and welcome to our channel and welcome to a brand new series on mini projects based on artificial intelligence. So today we'll be starting off with our first project, which is based on computer vision. So what we're going to be doing is we're going to be recreating one of those filters from Instagram or Snapchat, the dog face filter, using our own code with Python and OpenCV library. So let's get started right away. First of all, let me create a new Python file in the the directory which I have right here. I'm going to call it dogfilter.py. And second thing to note in this case is the libraries which we're going to be needing. So using pip install OpenCV or pip install numpy, you can install the libraries of OpenCV or numpy. You just need to type those commands in the terminal and we're going to be installing those libraries. So since I already have them installed, I'm going to directly go ahead and import those libraries. So CV2 is OpenCV, which is our first library. So numpy is not exclusively used in this code, but then OpenCV does require it in the backend, so make sure you import numpy as well. Otherwise, OpenCV is not going to work. So what we're going to be using today is the har cascade classifier, which is another method of OpenCV, and all those files need to be downloaded beforehand before you actually use them. So I have those downloaded and I've stored them in this path. Make sure this is the path you use when you download Python to store your files. They have to be in lib, site packages, CV2 and har cascade files. So let's copy this path since we're going to need it in the code, and let's call our cascade classifier and load our model right here. I'm going to call it face cascade is equals to, we have the function cv2.cascade classifier to load any of its models, and let's paste the path right here. So the model which we're going to be using is this one, which is called the har cascade frontal face default.xml. So it's har cascade frontal face default.xml. So once you are done with this, make sure you convert all the backward slashes into forward slashes. That's really important. Alright, so now we have our cascade classifier loaded as well as our library successfully imported. Now let's start with the next resource which we need, which is our filter itself. So I'm going to be using the dog filter here, so let's read that filter. Now make sure the filter image is right in the working directory of your Python project. So it is for me, but if it's not, please definitely make sure that you give the path here in this field. And let's show you guys how our filter is going to look. I am show, and let's call it filter comma dog. All right, and next is cv2.wait key to make sure we see the output. Okay, so running that will show us the filter which we're going to use. So yeah, there it is, the basic dog filter which we have. We're going to be using this filter today. And next thing I need is I'm definitely going to need the basic dimensions of our filter, right? Because we're going to use them later. So let's call it original dog height, comma original dog width along with that, and the number of channels, that is the number of channels which we have with RGB, which is 3 in this case. So that's dog.shape. All right, so the image, the relevant factors or the relevant dimensions will be loaded in our variables right here. And so now we need to convert our RGB image into a grayscale image. So how am I going to do that? So let's call a dog variable dog gray, and I'm going to use the convert color function of CV2. And what am I converting? I'm converting dog, and I need to convert it from RGB to gray. Okay, there we have it, and let's see how this image looks. So gray filter and dog gray. So this is our image. Wait key again, 0. Alright, so we have already seen the first image, but let's see how it displays again compared to the original one. So this is the grayscale image of our original filter. We're going to be needing this in the next function, which I'm about to show you. So next what we're going to do is we're going to convert this image into a binary format, right? It's either a black or a white. So for that we're going to be using the thresholding function. So let's call that function right here. And so I'm going to be creating, what I'm doing out of this thresholding function is I'm basically creating a mask. So this mask is the one which is going to be placed on our image. It basically works like any other mask which we use in real life. So let's do that. And what am I masking? What am I thresholding? The dog gray image, and the minimum value of pixels above which the pixels are converted to black is 10. And the method I'm going to use is binary inverse. Where is it? It's right there. So what this function is going to do is, with the help of thresh binary inverse, any pixel value, so grayscale values basically vary between 0 and 255. So any value that's above 10 is going to get converted to 0. 0 means black and 255 means white. So this is what our function is doing. It's going to create a mask like I'm about to show you. And we also need another mask which is the inverse of our original mask, where basically black is white and white is black. So bitwise not. So arithmetic operations can be performed on images since OpenCV ultimately recognizes them as basic values of pixels, original mask. Okay, so let's again show these two images and let's see how they look. Okay, so I have, first is my mask, and the name of the variable is original mask. Okay, next is I have mask inversed, where black is white, white is black, and it is original mask inverse. Okay, so running this too will show our mask. This is our first filter. Okay, so this is our mask. Basically this will be placed on our image, right? And so inverse mask will obviously look like this. Black is white and white is black, as I said. So now that we have our mask, we have everything which we need. Alright, so that sums up our first video, where we downloaded all the libraries and the files which we need for the project, meaning OpenCV, NumPy and HarCascade. And we also read our image of the dog ears filter, along with converting it to various formats which we need, meaning grayscale, and then thresholding the image to create the black and white mask out of it, which we're going to use in the later upcoming videos. So we are remaining with one last resource which we need, which is basically our own face, which is going to act as the subject for our filter. And we're going to do this using the webcam function of OpenCV, and we're going to do that in the next video, the following video. In case there's any problems with loading the libraries and downloading HarCascade files, do let us know in the comments, and yep, I'll be seeing you in the next video.